Hello guys, today let's try to implement a try in LeetCode. So what's a try? Well, it's a custom data structure that's used to know that given a prefix, whether any word of that prefix exists in a dictionary of words. Tries are also used to know whether a word exists in a dictionary or not. You may think that a hash map does the same thing, right? It gives an order one lookup for whether a word exists in a dictionary or not. Well, the problem here is that hash map can have collisions, and it might get difficult unless you are able to figure out a very good hash function to prevent those collisions. So in the try doesn't have this problem, but it does have some drawbacks which I'm going to discuss after implementing our solution. So let me just try to give you a visualization of what a try is going to look like. It's basically a graph base, and we are going to have a root node. It's an abstract node. It doesn't represent anything. And then let's say we have one word in our dictionary is code. In that case, we're going to have a node that's corresponding to the character C, then O, then D, and E. So every node is going to have n number of characters, and that many children it's going to have. So in our case, it's given that the number of characters are lowercase characters from A to Z. So that's 26 characters. So we have 26 children in our try node. So let's start with our implementation. So first, what I'm gonna have is a structure representing each node in the try. I'm making it a nested structure definition, and this is because a node has only meaning if there is a class try. So that's why it's a nested class. So we have struct node, and we have bool if a word is ending in this node or not. So that's represented by isEnd. Since it's a member, I'm going to have this m prefix to it. And so next what we're going to have is pointers to our child nodes. So that's vector of node star, and that's going to be m children. Now what we're going to have is our constructor, and since we know that I'm gonna have this static static number of characters equal to 26. This is because our values ranges from A to Z, so number of characters is this. So this is int. So for int I equal to 0, so int I equal to 0, I less than number of characters I plus plus, and we're gonna have our m children dot push back is gonna be a null pointer, because in the initialization we're gonna have all our children to be null pointer. And I'm also gonna make m is n to false. So if a word is actually ending in that node, I'm going to set it to true explicitly. Okay, so that's pretty much our constructor for a node, and we can actually end this class. Okay, now what other thing do we need? Yeah, so for the try class we need a pointer to our root node, which I showed here. So this is a root node, so we need that. So it's a node star root. Since it's a member, I'm gonna have it prefix m to it, and by default it's going to be null ptr. Okay, now for the constructor of our try node, we can have this m root equal to a new node, right? Okay, now what else? Now to insert a word into the try. So let's gonna first have a iterator, which is going to iterate to our try. So that's node iterator, and it's going to be a first pointing to our root node. And so then what you're gonna have is a similar for loop to this one, where you have iterating to each character in the word. So lenth, so each character in the word we are going to iterate. And what I need is since each children is represented in a vector, and I need a mapping of A to Z to numbers from 0 to 26. So that's what I'm going to call it as an index, and that is int index equal to word of I minus A. So this is going to convert this A to Z range from 0 to 26. And then what we're going to do is if our iterator dot and m children of index, if it's null, then we need to actually create that, because we are inserting a word. So if any of the character in that order is not present, we need to actually create that node, and then we need to increment our iterator. So we need to go to our next character. So that's what this line does, and that's pretty much it. And in the end, we have reached the last character, so we need to set this iterator of m is int to true. Right. Now how do we search for a word? The logic is pretty much similar to inserting. So the difference is that, if we encounter any of them as null, that means that that word was not inserted during this for loop here. So we can readily return false, because that word is not going to exist. And so we have and by the time this for loop has completed, we would have reached the last character. So what we need to return here is the last character. The node corresponding to it should have m is int as true if a word ends there. So we are searching for an exact word here, so we need to return itr m is int. Now to return whether a word starts with a given prefix, the logic is going to be pretty much similar, but the only difference is going to be that we don't need to return whether it's m is int or not, because we are just checking for a prefix. So we can just readily return true here. Okay, and here the string prefix, so we place word with prefix. That's sorry. And that's pretty much it. Let's try running this code. Okay, so static data member initialized out of line. Sorry guys, so we need actually we can do this now. Right, so we have our code test cases covered here. Let's try submitting this code. That's it guys. So our implementation of try is correct. Now the problem that you guys may notice here is that our try grows very rapidly. So since we have 26 children, the first root node will have 26 child, and then the one of its child is going to have another 26 children. So it's an exponential growth, and it's going to be 26 to the power of n, where n is the length of the largest word in our dictionary. So this growth is non-sustainable, as a try cannot be serialized easily, and so we need to keep it in memory, and so it's going to be really memory hogging. So the solution for this, in many cases, is going to be that beyond a certain length of maximum word, we're going to use some other data structure to store our data. and let's not deep dive into that discussion here. So a drawback of try, you can say, is memory most of the time. So that pretty much concludes tries and their use case and implementation. Hope you guys enjoyed this video. Please like and subscribe. See you on the next one.